Have you ever wondered what would happen if humanity suddenly gained the ability to watch the universe change almost in real time? For centuries, the night sky seemed frozen. The same constellations appeared night after night, giving the illusion that the cosmos barely changed at all. But that illusion has just been shattered. High above the Chilean mountains, one extraordinary observatory has begun opening a completely new window into space. Within its first observations, it revealed millions of galaxies, uncovered thousands of previously unknown asteroids, and captured details so vast that astronomers are now preparing for a decade that could completely transform our understanding of the universe. And what makes this even more exciting is that these are only the first steps of a mission that has barely begun. Before we continue, if you enjoy exploring the biggest mysteries of space and the latest scientific discoveries, make sure you hit the like button and subscribe, because the next 10 years could become one of the most exciting periods in the history of astronomy. The observatory carrying this enormous responsibility is named after Vera Rubin, a pioneering astronomer whose research changed the way scientists think about the universe. Decades ago, she noticed something strange while studying the motion of galaxies. According to the visible stars inside them, galaxies should have flown apart long ago. Instead, they remained perfectly intact. Her observations became some of the strongest evidence that an invisible substance, now known as dark matter, fills the universe. Although Vera Rubin never lived to see this observatory become operational, its mission continues the very question she spent her lifetime trying to answer. Unlike traditional telescopes that focus on one object at a time, this observatory has a very different job. Instead of staring at a single galaxy or a distant nebula for hours, it repeatedly scans enormous sections of the night sky. Every few nights, it photographs nearly the entire visible southern sky again and again. That simple idea changes everything. Each new image can be compared with the previous one. If something moves, brightens, fades, appears, or suddenly disappears, computers detect it almost immediately. In other words, astronomers are no longer looking at still photographs of the universe. They're beginning to watch the universe evolve. The difference may sound small, but it changes the kind of discoveries scientists can make. Imagine taking one photograph of a busy highway. You would see hundreds of cars, but you would never know where any of them were going. Now imagine recording the highway every few seconds throughout the entire day. Suddenly, every movement becomes visible. You can follow every vehicle, every change in traffic, and every unexpected event. The Vera Rubin Observatory is doing something remarkably similar for the cosmos. Even during its earliest observations, the amount of information collected amazed researchers around the world. Images contained countless stars, distant galaxies, glowing clouds of gas, and moving objects that had never been recorded before. Every observation added another layer to an enormous cosmic map that will continue growing for years. Scientists expect the observatory to collect an unprecedented amount of astronomical data, far beyond anything previous sky surveys have achieved. Among the most exciting early discoveries were thousands of newly identified asteroids. Most people imagine asteroids as simple rocks drifting through empty space, but they are actually ancient time capsules. Many formed during the birth of our solar system more than 4 billion years ago. They preserve clues about how planets formed, how collisions shaped our cosmic neighborhood, and how the early solar system evolved into what we see today. Some of these newly detected objects immediately caught scientists' attention because of their unusual behavior. A few rotate much faster than expected, challenging long-standing ideas about what large rocky bodies should be capable of surviving. Normally, an object made mostly of loose rock would begin breaking apart if it spun too quickly. Yet several newly observed asteroids appear to remain intact, despite rotating at astonishing speeds. Every unusual object forces astronomers to ask a new question, and every new question pushes science one step further. The observatory is also becoming one of Earth's most powerful planetary defense tools. While Hollywood often imagines giant asteroids heading directly toward our planet, reality is usually much less dramatic. Smaller objects enter Earth's atmosphere far more often. Most burn up harmlessly, creating brilliant fireballs across the sky. Detecting these objects earlier gives scientists valuable opportunities to study them before they arrive, improving future warning systems and helping researchers better understand near-Earth space. But asteroids are only one part of the story. Far beyond our solar system lie billions of galaxies, each containing countless stars. Many of those stars eventually explode in spectacular events known as supernovae. These explosions briefly become brighter than entire galaxies, allowing astronomers to measure enormous cosmic distances. By observing thousands of these events over many years, scientists can improve measurements of how quickly the universe is expanding. That question has become one of the biggest mysteries in modern astronomy. Different methods of measuring the universe's expansion continue producing slightly different answers. This disagreement has become known as the Hubble tension, and solving it could reveal entirely new physics. The Vera Rubin Observatory is expected to discover an enormous number of exploding stars during its mission, providing one of the richest datasets ever collected for studying cosmic expansion. Another exciting area involves objects that appear without warning. Every night, something changes somewhere in the sky. A distant star may brighten dramatically. A black hole may consume material from a neighboring star. A comet may suddenly become active as it approaches the sun. A previously unknown asteroid may cross a telescope's field of view. Until recently, many of these short-lived events simply escaped detection because no telescope was watching at exactly the right moment. Now that situation is changing. Continuous observations mean astronomers can detect temporary events almost as they happen. Instead of discovering them weeks or months later, scientists can point additional telescopes toward these objects immediately, gathering information while the event is still unfolding. That ability dramatically increases the scientific value of every discovery. Perhaps the most fascinating possibility involves visitors from beyond our own solar system. In recent years, astronomers confirmed that objects from distant star systems occasionally pass through our cosmic neighborhood before continuing their journeys into interstellar space. Each one carries clues about planets forming around entirely different stars. Every new interstellar visitor provides a rare opportunity to study material that originated light years away from our sun. And with its constant monitoring of the sky, the Vera Rubin Observatory could discover many more such travelers in the years ahead. Another possibility could be even more revolutionary. The observatory was designed not only to study what we can see, but also to investigate what remains invisible. Most people are surprised to learn that every planet, every star, every galaxy, and every living thing together account for only a small fraction of the universe. The majority appears to consist of dark matter and dark energy, two mysterious components that scientists still cannot observe directly. We know they exist because of the effects they have on gravity and cosmic expansion, but their true nature remains one of the greatest unsolved puzzles in physics. That is exactly why this observatory exists. By tracking the positions and shapes of billions of galaxies over many years, astronomers hope to build the most detailed map ever created of the invisible structure holding the universe together. Every tiny distortion in the light from distant galaxies acts like a clue, revealing where unseen matter may be hiding. Instead of searching for dark matter directly, scientists can watch how its gravity bends light across enormous distances. Piece by piece, those measurements may finally reveal how the invisible universe is organized. The observatory's enormous camera plays a critical role in this mission. It is one of the largest digital cameras ever built for scientific research. Every exposure captures an incredible amount of detail across a huge section of the sky. Processing those images is a challenge by itself. Advanced computer systems examine every pixel, compare it with previous observations, and automatically identify anything that has changed. The result is an ever-growing stream of discoveries arriving night after night. Instead of waiting months for new observations to be analyzed, researchers receive alerts almost immediately whenever something unusual appears. This transforms astronomy from a slow process into something much closer to real-time exploration. The amount of information expected over the next decade is almost impossible to imagine. Every clear night adds more observations than entire astronomical surveys once collected over many years. Artificial intelligence and machine learning are becoming essential partners because no human team could manually inspect every object. Sophisticated algorithms sort through enormous datasets, highlight unusual events, and help scientists decide which discoveries deserve immediate attention. Even with these powerful tools, researchers expect countless surprises hidden inside the data, waiting to be recognized years after the images are first collected. History suggests those surprises are inevitable. Almost every major leap in astronomy has revealed something nobody predicted. When Galileo first pointed a telescope toward Jupiter, he discovered moons orbiting another world. When Edwin Hubble measured distant galaxies, he showed that the universe extends far beyond the Milky Way. Radio telescopes uncovered pulsars that initially seemed so mysterious they were jokingly nicknamed signals from little green men. More recently, gravitational wave observatories detected ripples in space-time itself, confirming predictions made a century earlier. Again and again, better instruments have not simply answered old questions. They have created entirely new ones. That is why many astronomers believe the greatest discoveries from the Vera Rubin Observatory may involve phenomena nobody has imagined yet. Somewhere among billions of galaxies could be an entirely new class of cosmic explosion. Somewhere in the changing sky might be a rare object behaving unlike anything currently described in textbooks. Hidden within years of observations could be patterns that challenge existing theories of gravity or reveal unexpected properties of dark matter. Science advances by following evidence, and when observations disagree with expectations, understanding evolves. The observatory will also work alongside other powerful facilities around the world and in space. When it detects something unusual, Telescopes operating at different wavelengths can immediately investigate. Some specialize in infrared light, others in radio waves, X-rays, or gamma rays. Together, they create a much more complete picture than any single observatory could achieve alone. A sudden flash detected in visible light may later be connected to radio emissions or high-energy radiation, revealing details that would otherwise remain hidden. This cooperative approach is becoming the future of astronomy, where discoveries spread rapidly across an international network of researchers. One of the most exciting aspects of this mission is that the public will also benefit. Many observations and data products will eventually become available for scientists, educators, and students around the world. Future generations may analyze the same observations using techniques that do not even exist today. Just as old astronomical photographs continue producing discoveries decades later, the data collected during this survey could remain valuable for generations. Long after the observatory completes its primary mission, researchers may still uncover remarkable findings hidden within its archive. Perhaps the most inspiring part of this story is what it says about human curiosity. Every generation builds tools that allow the next generation to see farther than ever before. Ancient civilizations tracked the stars with nothing more than their eyes. Later came simple telescopes, giant observatories, spacecraft, and space telescopes orbiting above Earth's atmosphere. Each technological leap expanded our understanding of reality. The Vera Rubin Observatory represents another giant step in that journey. It is not replacing previous telescopes. It is adding a completely new way of observing the universe by recording how it changes over time instead of treating it as a frozen picture. Think about that for a moment. Somewhere tonight, while most of the world sleeps, a distant star may brighten dramatically. A new asteroid may quietly move across the background of stars. A supernova may begin lighting up a galaxy millions of light years away. An object traveling through interstellar space may briefly pass within reach of our instruments. Thanks to this observatory, events like these are far less likely to remain unnoticed. The universe is active every second, and for the first time, humanity has built a system designed to keep watching continuously. The next 10 years could answer questions that have puzzled scientists for generations. They may also replace those questions with even bigger mysteries. That has always been the beauty of science. Every discovery opens another door. Every answer leads to another question. And every time we think we finally understand the universe, nature reminds us how much remains unexplored. If you made it this far, you're a part of a community that refuses to stop asking questions about the cosmos. So before the next incredible discovery makes headlines, take a second to like this video and subscribe to the channel. It helps us continue bringing you the biggest stories from the frontiers of science and space. Now tell us in the comments which possibility excites you the most. Finding entirely new kinds of cosmic objects, solving the mystery of dark matter, or discovering something so unexpected that it forces scientists to rewrite what we know about the universe. Whatever the answer turns out to be, one thing is already clear. The night sky is no longer a silent, unchanging backdrop. It is a living record of an ever-changing universe, and humanity has only just begun learning how to read it.